In math practice, we are going to discuss a very important chapter which is lines and angles. We are going to discuss many type of different examples. So watch the video till the end and subscribe to math practice. Some definitions. If three or more points lie on the same line, they are called collinear points. Otherwise, they are non-collinear points. What is an angle? An angle is formed when two rays originate from the same end point. The rays making an angle are called the arms of the angle and the end point is called the vertex of the angle. You already know different types of angles. Like for example, acute angle measure is less than 90 degree, right angle measure is 90 degree, obtuse angle measure more than 90 degree and less than 180 degree. Straight angle means the measure is 180 degree. Reflex angle of an angle means 360 degree minus the measure of that angle. And full rotation angle means 360 degree. Next, two angles whose sum is 90 degree are called complementary angles and two angles whose sum is 180 degree are called supplementary angles. So when two angles are complementary, the total is 90 degree. And when two angles are supplementary, then the total measure is 180 degree. Two angles are adjacent if they have a common vertex, a common arm and the non-common arms are on different sides of the common arm. Then they are adjacent. Linear pair of angles as shown in the figure are adjacent angles that share a common vertex and a side and form a straight line. That means they are adjacent angles first of all, and the two opposite arms or the non-common arms lie on the straight line. Hence, the sum of the angles in a linear pair of angles will always be 180 degree. In the given figure, angle AOP and angle POB form a linear pair of angles. The definition which is much used. Vertically opposite angles are a pair of angles that are opposite to each other at a vertex when two lines intersect. A pair of vertically opposite angles will always have the same measure. So remember this, like for example in the given figure, there are two pairs of vertically opposite angles. The first pair is angle 1 and 3 which are vertically opposite and second pair is angle 2 and 4. And you can see that the measure of vertically opposite angles will be the same. Now we are going to prove theorem 6.1 which says that if two lines intersect each other then vertically opposite angles are equal. Let us see the proof. So we have two lines AB and CD which are intersecting at O. We have to prove that two pairs of vertically opposite angles are equal. Means angle AOC should be equal to angle BOD and angle AOD should be equal to angle BOC. So first thing is angle AOC and angle AOD. You can see they form a linear pair. Correct? So their total measure will be 180 degree. Similarly, angle AOD also forms a linear pair with angle BOD. So angle AOD plus BOD will also be equal to 180 degree. So now since both are 180 degree, equate them. So you will be getting AOC plus AOD is equal to AOD plus BOD. Hence, angle AOC and angle BOD will be having the same measure. Similarly, you can also prove that angle AOD and angle BOC will also have the same measure. Now some examples. Example 1. In the given figure, if angle POY is a right angle and A is to B, the measures A is to B are in ratio 2:3, then find the measure of C, angle C. Now, first of all, since A is to B is 2:3, so A is equal to sum 2 into X and B is equal to sum 3 into X. So now we know that A plus B will be equal to 90 degree. Why? Because angle POY is 90 degree. So the other angle will form a linear pair and its measure will also be 90 degree. So A plus B will also be 90 degree. Now, what does this mean? 5x is 90 degree. 2x plus 3x is 5x which is 90 degree which gives x is equal to 18 degree. So, when you put x equal to 18 degree, you get A equal to 36 degree and B is equal to 54 degree. Now, from the figure it is clear that angles B and C form a linear pair. Correct? So, their total measure will also be 180 degree. So, B plus C is 180 degree. So what is angle C? 180 degree minus B, which is 126 degree. Example 2. In the given figure, if x plus y is equal to w plus z, prove that AOB is a line. Now, if you want to prove that AOB is a line, what should you prove? That the total measure of x plus y is 180 degree. Then AOB will form a straight line. So now, first of all the four angles, the total measure will be 360 degree. So x plus y plus z plus w is 360 degree, but x plus y is w plus z. So in place of w plus z, just put x plus y. So 2 times x plus y is 360 degree, or x plus y is 180 degree. Since x plus y is 180 degree, AOB is a straight line. Next important example. In the given figure, ray OR is perpendicular to line PQ. OS is another ray lying between rays OP and OR. Prove that angle ROS is equal to half of angle QOS minus POS. Now first of all, see the diagram. So what is given to us? Angle POR. Angle POR is 90 degree. So what is angle POR? POS plus ROS. So angle POS plus angle ROS is 90 degree. Why 90 degree? Because OR is perpendicular. So now angle POS plus QOS. Angle POS plus QOS, it forms a linear pair. So that total is 180 degree. So now angle POS plus angle QOS is 180 degree, which is 2 times of 90 degrees. So 2 times of what is 90 degree? POS plus ROS. Hence angle POS plus angle QOS is 2 times angle POS plus 2 times angle ROS. 1 POS gets cancelled. So 2 in angle ROS is equal to angle QOS minus angle POS. Hence angle ROS is half of angle QOS minus angle POS. Next interesting example. In the given figure, you have to find the angles X, Y, Z and U. First of all, you are seeing many straight lines which are intersecting at a point O. Now first, angle COE and angle FOD. You can see that they are vertically opposite angles. So their measure will be same. We have just now proved vertically opposite angles will have the same measure. So what is Y? Angle COE, which will be equal to 50 degree. Now we have obtained the value of Y, which is 50 degree. Next, you can see from the diagram that X plus angle BOD plus angle FOD, the total is 180 degree because they lie on the same line. So 180 degree. So X plus 90 degree plus 50 degree, putting these values, we get angle X is equal to 180 degree minus 140 degree, which is 40 degree. Next, you can see again that X plus Y plus Z, again their total is also 180 degree. They also lie on the same line. So Z is 180 degree minus 40 degree plus 50 degree. Hence measure angle Z is 90 degree. Also U and X are vertically opposite angles. So angle U will have the same measure as angle X, which is 40 degree. These type of examples you can prove using any other logic also, but the answer will always be the same. So we have obtained X is 40 degree, Y is 50 degree, Z is 90 degree and U is 40 degree. Now a very important concept based on which many examples are asked. Parallel lines and a transversal. A line which intersects two or more lines at distinct points is called a transversal. So if you are having two lines and some other line intersect them at two or more points, it will be called as a transversal. In the given figure, we are going to see some angles which are based on two lines which are parallel. Remember over here M and N are parallel to each other and L is their transversal. So now if M and L are parallel to each other and L is the transversal, then you have some type of angles corresponding angles. You have 4 pair of corresponding angles. They will be 1 and 5, 2 and 6, 4 and 8, 3 and 7. Look at the diagram and just check it out, the corresponding angles. Next you have pairs of alternate interior angles. 4 and 6 are alternate on different side of transversal, so alternate. And angle 3 and 5, they are also alternate interior angles. Similarly, you can also have alternate exterior angles. They will be 1 and 7 and another pair is 2 and 8. Interior angles on the same side of the transversal. 4 and 5 are interior angles on the same side of the transversal L. Same way 3 and 6 are also interior angles on the same side of transversal L. Please remember the following results. They are very useful. First one, regarding corresponding angles. If a transversal intersects two parallel lines, then each pair of corresponding angles will be equal. Converse also, if a transversal intersects two lines such that the pair of corresponding angles is equal, then the two lines will always be parallel to each other. Similar result for alternate interior angles. If a transversal intersects two parallel lines, then each pair of alternate interior angles is equal. Conversely, if a transversal intersects two lines such that a pair of alternate interior angles is equal, then the two lines will be parallel. Third one, if a transversal intersects two parallel lines, then each pair of interior angles on the same side of the transversal is supplementary, means the sum will be 180 degree. Similarly, converse also holds. If a transversal intersects two lines such that a pair of interior angles on the same side of the transversal is supplementary, then the two lines will always be parallel to each other. Let us understand the results we have just now seen. First, the pairs of corresponding angles will have same measure. So suppose if lines M and N are parallel and L is a transversal, angle 1 will be equal to angle 5, angle 2 will have the same measure as angle 6, angle 4 equal to angle 8 and angle 3 equal to angle 7. Second results regarding alternate interior angles. Since the lines are parallel, angle 4 will be equal to angle 6 and angle 3 will be equal to angle 5. They are alternate interior angles. Third results for two lines which are parallel M and N and L is a transversal. The interior angles on the same side of the transversal will be supplementary, means angle 4 plus angle 5 will have 180 degree measure and angle 3 plus angle 6 will also have 180 degree measure. Another important theorem, lines which are parallel to the same line are parallel to each other, and this property can be extended to more than two lines also. That means suppose line M is parallel to line P and line N is also parallel to line P, then lines M and N will also be parallel to each other. Another very important example, if a transversal intersects two lines such that the bisectors of a pair of corresponding angles are parallel, then prove that the two lines are also parallel. First, let us understand what the statement says. What is given to us is, let the transversal AD intersect two lines PQ and RS. PQ and RS are two lines and AD is the transversal. Second thing is, you are having ray BE, which is the bisector of angle ABQ, and ray CG, which is the bisector of angle BCS. Also, it is given that these bisectors are parallel, means BE is parallel to CG. What you need to prove is the two given lines PQ and RS are parallel to each other. Now, first of all, as ray BE is the bisector, means the measure of angle ABE and a measure of angle EBQ will be same. So that means, in other words, angle ABE is equal to half of measure ABQ, since it is the bisector. Similarly, since CG is the bisector, measure angle BCG will be half of angle BCS. But BE is parallel to CG and AD is the transversal. So angle ABE and angle BCG, angle ABE and angle BCG, they will be equal. Why? Because now they are corresponding angles. BE is parallel to CG and AD acts as a transversal. So these two angles, angle ABE and angle BCG, are corresponding angles, so they will be equal. Now we substitute this in 1 and 2. So what we have is half angle ABQ will be same as half angle BCS. So that means angle ABQ will be equal to angle BCS. But angle ABQ and angle BCS, they are corresponding angles formed by the transversal AD for which two lines, PQ and RS, and they are equal. So just now we have seen the result that the corresponding angles are equal, then the two lines will be parallel. Hence, by the converse of corresponding angles axiom, we have PQ is parallel to RS. Now example 6. In the given figure, if AB is parallel to CD, CD is parallel to EF, and Y is to Z is in the ratio 3:7, find X. Now you can see that three parallel lines are given and a transversal is given. First of all, angles X and Y are interior angles on the same side of the transversal, so they are supplementary, means X plus Y is 180 degree. Now also you have Y and A, they are vertically opposite angles, so they will be having the same measure. Again, A plus Z, they are on the same side of the transversal, so they will also be supplementary. So A plus Z will be equal to 180 degree. But Y is A, so instead of A, put Y. So now you have Y plus Z also 180 degree. But now Y is to Z is 3:7. So suppose Y is some 3U and Z is some 7U. So what you have is Y plus Z is 180 degree, or 3U plus 7U is equal to 180 degree. So this will give you U as 18 degree. Since U is 18 degree, Y is 3U, which is 54 degree. But already from 1 we have X plus Y is 180 degree. So putting the value of Y as 54 degree, we get the value of X as 180 degree minus 54 degree, which is 126 degree. Another different type of example. In the figure 1, show that AB is parallel to EF. In the first figure, we have to show that AB and EF are parallel to each other. First of all, angle FEC plus angle DCE. They are interior angles on the same side of the transversal EC, and you can see that their total is 180 degree. So EF is parallel to CD. First of all, what we have obtained is EF is parallel to CD. Now also you have angle ACD. Angle ACD total measure is 22 degree plus 35 degree, which is 57 degree. Again over here, angle ACD and angle BAC, they are having the same measure, and since they are alternate angles for the transversal AC, you can say that AB is parallel to CD. So here we have used the converse of the theorems which we have seen previously, that if alternate angles are equal, then the lines are parallel. Similarly, if interior angles are on the same side of transversal and they are supplementary, then the lines are parallel. So first we have shown EF is parallel to CD, then we have shown AB is parallel to CD. So by the result, lines which are parallel to the same line are parallel to each other. We can say that AB and EF are also parallel to each other. Second part of example 7. In the figure 2, if AB is parallel to CD and CD is parallel to EF, that is given, then you have to find the measure of angle ACE. First of all, as CD is parallel to EF, so FEC and DCE, they are interior angles on same side of the transversal EC, so they are supplementary. Total measure is 180 degree. So angle DCE will be 180 degree minus FEC, which is 130 degree. Hence angle DCE will have the measure 50 degree. Now lines AB and CD are parallel to each other. So angle BAC and angle ACD, they are alternate angles for the transversal AD. So they will have the same measure. So now we have angle BAC is equal to angle ACD. But what is angle ACD? Angle ACD is angle ACE plus angle DCE. So angle ACD is angle BAC, angle BAC is 70 degree, hence angle ACE plus angle DCE will be equal to 70 degree. So angle ACE is 70 degree minus angle DCE, which is 50 degree. So angle ACE is of measure 20 degree. Now some objective questions. True or false? All linear pairs are supplementary. It is true because linear pair means total is 180 degree. Second one, true or false? All supplementary angles form a linear pair. This is false because for forming a linear pair you need a common arm and the other two arms should be exactly opposite to each other. So all supplementary angles need not form a linear pair. Third, true or false? Angles forming a linear pair can both be acute angles. This is false because when they form a linear pair, total measure is 180 degree. If one of the angles is acute angle, means measure is less than 90 degree, the other one has to be more than 90 degree. So other one has to be obtuse. Fourth one, if one angle forming a linear pair is obtuse, the other one will be, fill in the blank, acute. Just now we have seen. The measure of an angle which is 3 times its supplementary angle is, check it out, the measure of an angle is 3 times its supplementary angle. So what will be that measure? It will be 135 degree. Sixth one, the supplementary angle of the complementary angle of measure 45 degree will be what? So first of all, complementary angle of 45 degree means it will be 45 degree. And the supplementary angle of 45 degree would be 180 degree minus 45 degree. So that will be 135 degree. Now some assignment examples. Please solve the assignment examples so that the topic is clear. First one, find the value of x for the given figure. So in the given figure you can see the total measure of all the 3 angles is obviously 180 degree. So the measure of angle x should be 25 degree. Second one, 2 lines AB and CD intersect at O. If angle AOC plus angle COB plus angle BOD is 270 degree, then what will be the measure of angle AOC? It should be equal to 90 degree. You can draw the diagram and check it out. Third one, in the given figure, determine the angle X. Over here, it is very clear that 3 lines are given to you over here, and since they are parallel, you can find the measure of angle X and it should be equal to 285 degree. Assignment example 4. In the given figure, L1 and L2 are parallel to each other and L3 and L4 are parallel to each other. You have to find y in terms of x. And the correct answer from the option is 90 degree minus x by 2. Now you try to see the figure and the hint is what will be 2y. 2y means the total of that angle, measure angle 2y is 180 degree minus x. So value of y will be 90 minus x by 2. Next one, if L is parallel to M, what is the value of x? Here the answer is x is 60 degree. What is the hint? You will get 2 equations over here. Solving them you will get the value of x is 60 degree. Correct? So first equation is x plus 15 and 2y plus 25 will be equal, vertically opposite. Same way you have 3y and x plus 15 alternate angles. So solving this you should get value of x as 60. Assignment example 5. If L is parallel to M, then find the measure of angle x. The answer is 105 degree and the hint is by seeing the diagram and solve will be getting the value of x as 180 degree minus 75 degree, which will give you 105 degree. Next one, if lines L and M are parallel, then the value of x is what? The answer is 35 degree. Here the hint is you will get x as 180 degree minus the sum of 90 degree plus 55 degree. This is an important chapter. So in case of any query, please write in the comment section. It will be solved. Please like and share the video and subscribe to Math Practice for many such videos. Thank you.